Hello and welcome back. In this video I will discuss few problem based on concept of two-dimensional motion. If problem is formula based, well and good, use those formula which you know. If you think you cannot directly apply formula, the concept of two-dimensional motion is it is equivalent to how many one-dimensional motion? Two independent and perpendicular one-dimensional motion. That is, one must visualize instead of one particle, how many particles are there? Two moving in mutually perpendicular direction. If you keep this concept in mind, I'm pretty sure you will be able to solve each and every problem. First question, particle is moving in 3 dimension. Its position vector is given, x component, y component and z component. And this position vector is function of time. First part, instantaneous velocity. So you can directly use formula for instantaneous velocity. You know, velocity is equal to dr by dt. You have basic idea of derivative. So first term we need to differentiate is 4 plus 2t. I cap is constant, so let me write I cap first, and then derivative of 4 will be 0 and derivative of 2t is 2 is constant, derivative of t with respect to t is 1, so you're left with 2. Second term, again j cap is constant, 3 derivative is 0, 5t derivative is 5 plus 4t square derivative is 8t. Third term, k cap, derivative of 2 is 0, minus 2t minus 2 minus 3t square is minus 6t. So this is expression for velocity. Let us simplify this. So velocity is equal to 2i cap plus 5 plus 8t j cap minus 2 plus 6t k cap. Second part, instantaneous acceleration. Acceleration is the rate of change of velocity. So differentiating velocity, this is expression for velocity, we get first term will be 0, second term 8 j cap because 5 is a constant minus 6 k cap. This is expression for acceleration. We know component of acceleration, y component and z, x component is 0, so we can easily find its magnitude and direction. Next question, figure shows 3 paths for a football kicked from ground level. So arrangement is quite clear. Ignoring effect of air, so we will consider motion to be projectile motion. Rank the paths according to a time of flight, initial vertical velocity component, horizontal velocity component, of course initial, and initial speed greatest first. So we have to rank time of flight, x and y component of initial velocity and initial speed. Let us start with B, initial vertical velocity component. According to diagram, all three attains same maximum height, and you know what is formula for h? It is uy square by 2g. I have suggested always use formula in terms of x component and y component, not u cos theta and u sin theta. That is, don't say maximum height is u square sin square theta by 2g. As for all three path, h is same as well as g is same. So what you expect? uy1 must be equal to uy2 is equal to uy3. So initial vertical component of velocity is equal. What about time of flight? How you find time of flight? The formula is 2 uy by g. As y component is same, so what will be time of flight? Equal time of flight 1 is equal to time of flight 2 is equal to time of flight 3. C part, what about horizontal velocity component, initial horizontal velocity component? Range you know is x into time of flight. Look at diagram. R1 is less than R2 is less than R3. R depends on initial x component of velocity and time of flight. All three has same time of flight, so they differ in initial horizontal velocity component. So as x component of velocity increases, what will happen to range? Range will also increase. So relationship, range is directly proportional to initial horizontal velocity component. So ux1 is less than ux2 is less than ux3. And as far as part D is concerned, initial speed, if you know x and y component, you can find magnitude of that vector using formula under root x component square plus y component square. So u is equal to under root ux square plus uy square. So every particle or every football has same y component that differ in x component. As x component increases, speed will increase. So relationship will be u1 less than u2 less than u3. So this is answer for part D. But one note of caution, you have to rank and you have to write greatest first. So in every case, these two parts, there is no issue, they are equal. Greatest first, the third football, then second, and then first. Same thing for D part. Write answer in that form instead of a relationship like this. Next question is a very important conceptual question. Amount of time it takes to reach, it takes each of projectiles in figure to hit the ground. So we have to find time taken by projectile to hit the ground. First, think about this and then answer. Time taken depends on what? Let me start from here. Number 1, distance. Number 2, displacement. It depends on distance or displacement. If you have to choose one out of these two, what you will choose? Obviously, distance, it cannot depend on displacement, because suppose you start from point A and you are back to point A after say 2 hours. How much is your displacement? 0. But time elapsed is not 0, it is 2 hours. So time cannot depend on displacement, it depends on distance. But finding distance is a very difficult task. You know that from one-dimensional motion. It is actual path length. So I am adding third point, component of displacement. Component of displacement. So this one is correct. It depends on component of displacement. And of course, apart from component of displacement, initial velocity component of all components should be in same direction, and acceleration component. This is how one can find time. So these three, number 1, component of displacement, number 2, initial velocity component, and number 3, acceleration component. So come back to this problem in hand. Let me first define x-axis and y-axis for every case. I am showing it here. This is x-axis, downward I am taking as y-axis. Now, figure A, B, C and D. Figure A, B, C and D. What you find is displacement along y-axis is same, 10 meter. Apart from displacement, in order to find component, correct word is component of displacement. So apart from component of displacement along y-axis, we need to know initial velocity component along y-axis in all 4 cases, A, B, C, D. How much is initial velocity in this case it is 0. In B, C, D it is along x-axis. So in all 4 cases, how much is initial velocity along y-axis? 0. And how much is acceleration in all 4 cases? G. So how much time it will take to reach ground? same time. So time taken in A, B, C and D, first case, second case, third case and fourth case, it will take same time, say T naught. In part E, in this part, as displacement is 20, so time taken will be greatest. So in this case, time will be greatest. So TA equal to TB is equal to TC is equal to TD and is less than TE. So again, if you want to find time, first thing is component of displacement, then initial velocity component, and finally acceleration component. So focus on that. You can easily solve difficult questions where you are supposed to find time. Next question, projectile is thrown with an initial velocity xi plus yj. If the range of projectile is twice maximum height reached, then we have to prove this relationship. So given is range of projectile is twice maximum height. So range is equal to 2 times maximum height. How you find range? 2 into ux into uy by g, and maximum height is uy square by 2g. Simplify this expression, this t will cancel out, g cancels out, 1 uy will cancel out. So what we get? 2 ux is equal to uy. According to question, how much is x component of velocity? X. And how much is y component of velocity? Y. So how much is y equal to 2x? At what an angle a projectile should be launched so that horizontal range is n times maximum height attained? Use formula for range and height. Range, you know, is, first of all, condition is range is equal to n times maximum height. Range is 2 ux uy by g and height is uy square by 2g. So 4 ux equal to n uy. Now let us do one thing. Let us involve theta, as nothing is mentioned. So by default we consider this sort of situation. Angle with horizontal is theta. So substitute value of ux becomes u cos theta and uy becomes u sin theta. You will cancel out. So what you get? Tan theta is equal to 4 by n. So theta is equal to tan inverse 4 by n. If you don't know what is meant by the tan inverse, then write your answer, tan theta equal to 4 by n. Next problem, range and maximum height is given. We have to show initial speed is 5 root g and angle of projection. So use formula for range and maximum height. Range, you know, is 2 ux uy by g and maximum height is uy square by 2g. So divide h by r. H by r is equal to uy square by 2g divided by, or you can write like this, simplify, g will cancel out, this is equal to uy by ux into 1 by 4. From vector, you know, y component by x component of a vector is equal to tan of theta, where theta is angle between vector and positive x-axis. So for this uy by ux we can write tan theta, so it becomes 1 by 4 tan theta equal to h by r. Substitute value of h and r. H is 8 meter, r is 24 is equal to 1 by 4 tan theta. So how much is tan theta equal to 8 by 6? That is 8 by 6 is 4 by 3. So how much will be sin theta? We have to prove in terms of sin theta. if you know tan theta, how to find sin theta. I will advise you one thing. Whenever from one trigonometric function you want to find value of another trigonometric function, in physics what you can do is start with a right angle triangle, draw a right angle triangle, draw like this. Suppose this angle is theta. Tan theta you know is opposite side by adjacent side, so this must be 4 by 3. And if this is 4, other side is 3, hypotenuse must be 5. So from same diagram, how much should be sin theta? Opposite side by hypotenuse, that is 4 by 5, equal to 0.8. So part B, you have to show that angle of projection is sine inverse 0.8. That part is over. Now first part, initial speed of projection. So how much is initial speed of projection? How to find that out? So you know tan theta, range and height. So from this equation, if you substitute value, how much is uy equal to? Under root 2g, h is 8, so equal to 4 root g, and then use this one to find ux. R is 24. 24 is equal to 2 by g into ux. We have to find ux, and uy is 4 root g. So how much is ux equal to? Simplify this. It is equal to 3 root g or not? So how much will be u? U is under root x component square plus y component square equal to 9g plus 16g under root is equal to 5 root g. This is your first part. Next problem, a stone thrown horizontally. Keep this thing in mind. It is thrown horizontally from top of 24-meter tower, hits the ground at point 18 meter from base of tower. Ignore any effect due to resistance. G is 9.8. Find speed with which stone was thrown, speed of stone just before it hits the ground. First, draw a diagram. It is thrown from top of 24-meter towers. Suppose this is ground level. This is tower. H height equal to 24 meter. Thrown horizontally. We have to find the speed. Say u. And where it strikes at distance, say x0. x0 is 18 meter from tower. So it hits here. Obviously, path it will trace a parabola, projectile motion. So this is path traced, a curve like this. In order to solve, let us start with step 1. Define x-axis and y-axis. So in same diagram, let us show this is say x-axis, this downward is y-axis. Then ux is equal to u, uy is equal to 0, ax is equal to 0 because acceleration is acceleration due to gravity which is vertically downward, and ay is equal to plus g because you have taken downward to be positive direction. Find speed. Now the concept is think in terms of how many particles? 2, one moving along x-axis, another moving along y-axis. So always keep that idea in mind. This displacement of 18 meter from base of tower along horizontal is due to which motion? Along x-axis. So can we write some equation? But before that, suppose time taken is t0. Time taken is t0. Then x0 should be equal to u into t0. We have two unknowns, u as well as t0. How you find time? By taking component of displacement. You know y component of displacement or not? So second equation along y-axis, I am directly writing it. Displacement along y-axis, y naught is equal to uy t naught plus half ay t naught square. Substitute numerical values. Y naught is plus 24 because you have taken downward to be positive. Y component is 0 plus half 9.8 into t naught square. So number 2. From equation 2, find out t naught. Substitute that value in equation 1. And in equation 1, x naught you know is 18 meter. The moment you substitute value of t naught, what you will get? U. And for part B, what method we will follow? At B, what we can do is, to find speed, let us first find x component of velocity and y component of velocity. As acceleration along x-axis is 0, so Vx is equal to Ux and Vy will be Uy plus Ayt. Uy no is 0, Ay is g, time is t naught. So how much will be speed with which it hits ground? Under root Ux square plus g t naught whole square. Substitute value, you will get to answer. Next question. An airplane flying horizontally with speed 49 meter per second releases a bomb at height 490 meter. Find time taken by bomb to reach ground. How far will the bomb fall on the ground from the point vertically below point of release? So convert into a diagram. Suppose this is ground level. Plane is flying at height 490 meter. So this is h. And this is your plane flying horizontally with speed u, 49 meter per second. This h is 490 meter. A bomb is released. Now tell me, the moment this bomb is released, in what direction it will move? Will it fall vertically downward? We have discussed this concept. I have mentioned it number of times. Concept of inertia. Due to inertia, that bomb will also move in same direction. And due to inertia, what is same? Velocity. So immediately after release of bomb, its velocity is 49 meter per second, or speed is 49 meter per second, and direction is horizontal, same as that of plane. So again I am repeating, due to inertia, velocity is equal, never acceleration. Word is velocity, so magnitude as well as direction. Subsequent motion of this bomb is projectile. How to solve? Start with what? X-axis and y-axis. Suppose this is x-axis, this is y-axis. We have to find time taken. How you find time? Component of displacement, initial velocity component, acceleration. So obviously we'll consider motion along y-axis. How much is displacement along y-axis? 490. So 490 equal to, how much is y component of velocity? 0 plus half, how much is a? 9.8 into t naught square. Simplify, you will get to t naught. And as far as second part is concerned, how far will the bomb fall? It falls here from this position. This is x naught. Which motion you will consider? Along x-axis. So x naught will be equal to ux into time taken is t naught. Ux is 49. In previous part we have calculated t naught. Substituting value of t naught, you can find out how much is x naught. A book slides off a horizontal tabletop with speed 1.2 meter per second. It strikes the floor in 0.4 second. Find height of tabletop from ground or floor, and B, horizontal distance from edge of table to the point where book strikes the floor. So first, as usual, draw a diagram. Suppose this is tabletop, this is ground level. Book slips off or slides off with initial speed u. First thing, we need to define x-axis and y-axis. Suppose this is x-axis, this is y-axis. So what you will visualize, how many books you shall be dealing with. 2. One moving along x-axis and then moving along y-axis. We have to find this height and distance where it hits. Subsequent motion is projectile. Now you have solved, or we have discussed, number of problem of this type. Now let us write equations. Along x, that is x naught, should be equal to u into t naught if time taken is t naught. Mention it here, time taken is t naught, and h equal to initial velocity along y-axis is 0, acceleration is g, h equal to half g t naught square. Second equation, u we know, t naught we know. So from equation 1 you straight away get x naught 1.2 into 0.4, and if you know t naught, what you can find, h will be equal to half into 9.8 into 0.4 whole square. So you can easily solve both the parts. Next problem, a projectile is thrown from a point in horizontal plane such that horizontal and vertical component of velocity are this and this. What will be range of projectile? So you are supposed to find range, and velocity components are given, initial velocity components are given, and it is projected from horizontal plane. So we don't know at what angle it is projected. Instead what we know is how much is x component of velocity and how much is y component. So range, you know, in terms of x and y component is 2 ux uy by g equal to 2 into 9.8 into 19.6 by 9.8. So it is 2 into 19.6. So you can easily simplify. This is your answer.